And now let me ask the second team, which is led by Professor Olga Štěpánková, and she will introduce.
Good morning, honorable directors and management of the CIRC, and good morning, all this esteemed audience. Let me introduce very briefly a small team dedicated to biomedical engineering and assistive technologies. We have the core of the team is based on 4 PhDs. I mean people with PhD title, and they are complemented occasionally by some additional stuff because we are cooperating quite closely, for example, with the team of Docent Hanna from Biomedical Engineering faculty. So sometimes if their financial side allows, they are complementing as well. Moreover, of course, the important part of the work is ensured by our PhD students. The 2 PhD students in the last year have been Jaroslav Cibulka and Milan Němý. Milan Němý successfully defended, and we are very proud of him because he has been our PhD student for quite a long time, and we have been supervising her together with Lenka Mysloušová. Further, the team was in the last year joined also by few more PhD students for which we have not been direct supervisors, but we have been supervisors specialists for Hedlička, who works with Dr. Hanna, and Denis Ozdemir, who works with Dr. Holmerová, and these students make sort of a bridge for us with other domains, what is very useful. The team has been working pretty hard in the last year, and we have accomplished quite a few very good papers, namely 4 papers in Q2 in index journals, 4 papers in Q1, 2 of which are even in D1. So we are very proud about this, and in a few minutes you will have a chance to listen to my colleagues who have been authors of these papers. The last paper which will be presented to represent activities of our group is that one of Denis Zdráhal, who works on a project which has been started last year, and it will continue to the year 25, dedicated to analysis of studied results. So this is what we will be hearing in our program. Last year, we had to finish 2 European grants where we have been involved in, namely citizen scientists investigating cookies and applications, and the grant dedicated to dementia intersectional strategy for cooperation and training, and have been in contact with many European centers caring for people with dementia. Well, of course, we are doing our best to get, well, I have to add that we are working quite a lot on in cooperation with the COCSIS department. We have been involved in their project, and commonly we have applied for some new projects, and these are the additional projects we have applied for as well. For the grant agency of Ministry of Health, they are still in hope that they will be awarded. CHIRC, we have applied as well, but unfortunately, due to lack of resources, the project is not financed, though it was very highly evaluated. So I will pass the floor to my colleagues, and the next one will be Milan Němý, who will be talking about this. about his PhD thesis and the latest papers.
Right. Good morning, everyone. My name is Němý, and I'm a postdoc researcher in the BEAT group. And today I would like to present in these few minutes our research on medical imaging, MRI processing, and Alzheimer's disease. And I'd like to note here that this is a collaboration between CERC and a few other institutions, such as Karolinska Institute from Sweden, or German Center for Neurodegenerative Diseases in Germany, or as well local ones such as Malta University Hospital. To just tell you a little bit about the context here, we're going to talk about the cholinergic system, which is part of the human brain, which is dedicated to cognitive processes, which is learning, attention, and memory. It's a very important one. You can see it on the right side, and it's denoted by a pink color. And the crucial thing here to mention is that this system is vulnerable to Alzheimer's disease, and it's one of the first ones to be affected. And it's also the reason why it is targeted by the current line of treatment. During one of the previous colloquia, I mentioned the articles in under point 1, where we created an algorithm to find spatial layout in living patients. So this was the first to segment these pathways in living people, actually. And we got this too already. And now we published a paper in which we evaluate this in Alzheimer's disease patients. So we took this one step further, and we published this in the Brain journal. So the main results, the most interesting ones, would be probably that we found out that there are some diffusion properties in these pathways which can be easily captured with magnetic resonance imaging. And using some clever post-processing, we can actually see that these measures are actually extremely sensitive to changes in Alzheimer's disease. So that's what we see on the right side, in the right column, which shows Alzheimer's disease brain in different brain slices. So these are the yellow part, which is significantly altered places in the brain. But to our surprise, we also saw that the brain was already changed in something called subjective cognitive decline, which is a preclinical state which isn't discoverable by any other means which are used in today's clinics. But we can use our method to actually see that there are some changes already. And our method can also show the spatial layout of these changes. So they are modes in the back of the head, in the posterior parts of the brain. And yeah, so why is this significant? First, it is, of course, these results which I just told you about. So this is this new knowledge about brain. And secondly, it's the method itself. So this is another piece to validation of the method. And since this publication and even the pioneering one, we've been contacted by a number of research teams around the world, and we begin some lines of collaboration. So we're very happy about it. I would like to also mention here our publications. So the one involved, that's the one I just talked about. And I'm happy to announce that we also published one last week, which is more of a systematic review, where we put our research as a core of this review of this field, and to put this into a context. We also bring this information in conferences. I also appeared in a cheap radio and radio journal, and I've been invited to give scientific lectures at Harvard Medical School and Wednesday. Thank you for listening.
So good morning, everyone. I am Huptych, and I would like to present the results of pooled analysis for two out-of-hospital cardiac arrest clinical studies. This analysis was a cooperation with Department of Cardiovascular Medicine of the General University Hospital in Prague and Center for Resuscitation Medicine in the Minneapolis. There are two related papers for the analysis. The first one describes the result of first clinical study, which was called Prague-OHCA, and these results were published in the Journal of the American Medical Association in the 2022, and this paper was crucial for the next cooperation, for the next analysis. And the second paper described the pool analysis itself, and this paper was published in the eClinicalMedicine journal under the Lancet publisher in the 2023. Both of the journals are Q1, V1. So let me briefly describe the Prague-OHCA trial for the context. Out-of-hospital cardiac arrest is a really serious health state, when it's necessary to start immediately some resuscitation. So very often scenario is that after the cardiac arrest, some bystander call the emergency and start cardiopulmonary resuscitation. Then the emergency medical service arrives to the place and start the professional cardiopulmonary resuscitation, and of course transport of the patient to the hospital where the treatment can continue. The Prague-OHCA was a randomized clinical trial. The leader of the study was Professor Bělohlávek from the General University Hospital in Prague. And the main goal, or the goal of the study, was to compare two out-of-hospital cardiac arrest treatment approaches. The first one is called standard, and or also advanced cardiovascular life support. And the second one is called invasive, where two specific devices were used. The first one is called LUCAS. It means Lund University Cardiopulmonary Assist System. You can see the device on this picture, and this device is used during the transportation by EMS. And the second specific device is called ECMO, is extracorporeal membrane oxygenation, and this device is used after the admission to the hospital. During the trial, 4,345 patients were assessed for enrollment to the study. However, only 256 patients met the criteria to include, 132 in the standard and 124 in the invasive arm. And the primary outcome of the study was survival with a good neurological outcome at the 180 days after randomization. There were also two secondary outcomes, cardiac and neurological recovery at the 30 days after randomization. And we reported also survival analysis in 180 days. Briefly, some results of Prague-OHCA. Unfortunately, the difference between standard and invasive arms in the primary outcome was not proved. The trial was possibly underpowered to detect a clinical relevant difference because the trial was stopped by the Data and Safety Monitoring Board with 256 probands, which was under the planned sample size in the study. However, the difference in the neurological recovery in 30 days and the difference in the survival in 100 days were proved. The absolute difference in neurological recovery was 12.4%, and here you can see the survival analysis, Kaplan-Meier survival analysis, where the darker line is the invasive approach, and you can see the difference between these two approaches. At the time the Prague-Uchka study was published, there was only one other published clinical trial in this domain with similar protocol, with similar purpose, and it was the Arrest trial from Center for Resuscitation Medicine in Minneapolis. The leader of this study was Professor Dimitris Yiannopoulos, and we cooperate with the team of the Professor Yiannopoulos to prepare the pooled analysis of data for both studies. So finally, the total sample size for this pooled analysis was 286 probants, 147 in standard arm and 139 in the invasive arm. The primary and secondary outcomes were same for the both studies. There was no problem. There was one difference because the Arrest trial contains only ventricular fibrillation, initial rhythm of the cardiac arrest, while the Prague-Uchka contains more initial rhythms for the cardiac arrest. Therefore, we reported the analysis for whole data set and for specific ventricular fibrillation subgroup. And because very important subgroup is also patients with cardiopulmonary resuscitation longer than 45 minutes, we also reported analysis for this subgroup. Standardly, the analysis which is reported is called intention to treat. It means it's given by the randomization. However, this is a clinical trial in the real life, and sometimes it's necessary to switch the treatment. And therefore, for the transparency, we also reported the as treated analysis and per protocol analysis in the paper. Then the main outcome or the primary and secondary outcomes were reported as absolute difference, and moreover were reported also Kaplan-Meier survival analysis and series of Mantel-Hansels model for examining the association of treatment assignment factors and outcomes. Some results in the data pooled analysis, the final interpretation of the results is that in patients with the refractory out of hospital cardiac arrest, the invasive approach significantly improved 30 and 180-day neurologically favorable survival. The absolute difference for the primary outcome was 12.7% in favor of invasive approach, and the absolute difference for the neurological recovery was 15.4% in favor of invasive approach. Here you can see two examples for the survival analysis. On the left figure, in the left figure, you can see the Kaplan-Meier survival analysis for intention to treat for whole data set. The blue line is the invasive approach, the red line is the standard approach. There is a significant difference, and higher difference we can observe if we prepare analysis or the survival analysis for the subgroup of patients with cardiopulmonary resuscitation longer than 45 minutes, which is very important result. And finally, I would like to show this result. It's a result of the Mantel-Hansels model, where I would like to highlight the results for the time of cardiopulmonary resuscitation, again for the category of the patients with resuscitation longer than 45 minutes, when the results are significantly in favor of invasive arm and invasive approach of the treatment, and the difference of the risk is more than 30%. So thank you for your attention.
Questions? No?
So I think now it's my turn. I will probably use the microphone. No, no. Does it work? Okay, good. My name is Zdráhal, and I'm going to talk about our approach to analyzing student data, especially engineering and first year data. Here we are interested in the data, how students organize exams. We worked on this area for something like, we'd say, distance education for something like 15 years at the Open University, and on standard education face-to-face, say 5 years with the Czech Technical University as a partner, Faculty of Mechanical Engineering, and then also now we have added me on this and trying to support them. Basically, the problem is that too many students, especially in the first year, and especially in engineering domains, fail. And the failure is, say, level of 40% students fail, which is economic problem, social problem, and I would say it's a loss of their will to do something. So what we want to do is somehow, based on the successful stories, which is data of successful students, somehow analyze the way how they work with the how they organize their exams, and use it as a kind of exam trajectories. And those who want to use it, those who want to follow it, can somehow do it and achieve better results. So this is what everybody knows. This is the academic year. As you can see, there is the green things are the green lines are tutorials, and the red lines are exam periods. We divided these red lines internals into 6 weeks, and we are interested only in the D1, D2, because it's the first one, and everybody is surprised suddenly that there are exams, and they must do something, produce something. So this is what we want to analyze, and we want to find out how to organize, how to help students to organize. The rules are basically standard, which is in day D2, students should get at least 15 credits. If they don't do it, they fail. If they have, it's not the full number of credits they need to be successful, but this is the minimum so that they can continue. And in the summer, the minimum is 30. If there's 60 or more, so they satisfy all requirements. But if they have less than 60 and more than 30, they can continue and go to the next year with burden of a need to fix it. So so now we are interested in D1, D2, divided into 6 weeks of exam period and how students should organize it. And we would like to organize these. Typically, there are 3, maybe sometimes 4, but typically 3 very strong subjects where you can get most of the credits. So at least enough to survive. So this is mechanical engineering, and it's mathematics, 7 credits, constructive geometry, 5 credits, physics, 5 credits. Obviously, you can also somehow put it together with from welding and all this thing, but you will fail eventually. You need some of these some of these strong subjects. We went through the other faculties, and perhaps with the exception of bioengineering, in every faculty of Czech Technical University, there are some 3 key subjects that students must somehow pass. Okay. How to code it so that we can somehow handle it formally. So we say we will give points if student didn't attempt the exam, so it's 0 point. If failed the first attempt, so it's 1. Failed second attempt, so it's 2, and it's failure, because we don't allow something like extra. You see, these are just standard rules. And if students get pass whatever mark, so it's 3. And you can see from that that it looks like we can express the result week by week by this xn number, which says what the student achieved so far. It doesn't matter for the future how they got there. So this is an example. Week 1, one student mathematics and failed. State 1. Second and third week, no activity. Still state in state 1. In week 4, passed mathematics for E. Who cares that it was for E? But it was somehow 3 points. And if you look at that, so he achieved eventually in week 6, this student 63 points, which is all equal. And these xn satisfy conditions for Markov chains, which means the next step doesn't depend. For the next step, it's not important how they got there to the previous step, but only where they are. Okay, so you can express it as a kind of graphically in this way, where the upper in the lower graph, the upper number shows the number of points, and the lower number in parentheses shows how many students went through this path. And now look at that. These are the left part are successful students integrated all into the graph. And you can see that eventually they expand a little bit, which is there are different ways how they got there, but eventually they got to 63, which is all success in all key subjects. The right graph expands, and you can see that they don't, somehow it doesn't converge. So this is example of successful students, an example of failing students. Okay, the key problem is what is the first line, which is retention of a student, is prediction plus intervention. So you must identify that student is in trouble as early as possible, so that somebody can intervene, some academic can intervene. It's a standard feedback system, and it must be done in time. Otherwise, if you at the end of in week 6, if somebody say that he should do or she should do mathematics, so it's in trouble. So we did with mechanical engineering, which was in these years, and these were the results before they started using this our approach. So the best result was 33 points, 33% of failing. When they start applying our intervention system, by the way, developed by their academics. So this was important contribution of people who are responsible for education of mechanical engineering, but they developed techniques how to put the feedback. And you can see that the percentage of failing students dramatically decreased. I was calling to the Ministry of Education how much they are getting per one saved student. And these numbers are not speculations, these financial numbers, they are real numbers what the faculty got for using this approach. 27 million crowns in 4 years, it's not so bad. By the way, obviously these students, some of these students who were saved didn't satisfy all the requirements for the next academic year. And they somehow pushed the problem back in front of them. So they must eventually to satisfy all the conditions. So they must pass all the necessary exams. But they are not, they have a little bit, they have this feedback saying, you should do, now is time to do this. So somehow motivate and tell them what is the next move. I think that's it. The whole thing. The whole space.
Okay, thank you very much.